ever wondered what ground resistance testing is and why it's crucial in electrical engineering? Our world is electrified, and ensuring safety and efficiency in this electrified world is paramount. That's where ground resistance testing comes into play. This process measures the resistance of the Earth's ground, which is vital in preventing electrical faults, ensuring safety, and maintaining electrical system performance. Ground resistance testing is the unsung hero in electrical engineering, working behind the scenes to keep our electrical systems running smoothly. And guess what? There's not just one way to do it. We'll be delving into 4 different methods of ground resistance testing: stakeless testing, selective testing, soil resistivity testing, and fall of potential testing. Each approach has its unique benefits and applications, making them vital tools in an electrical engineer's arsenal. Ready to dive into these 4 methods? Here we go. First off, let's explore the stakeless method of ground resistance testing. This method has revolutionized the way we approach ground resistance tests, offering a practical solution for challenging environments. The stakeless method uses 2 clamps, one acting as a signal generator and the other as a receiver. It's a smart and efficient way to conduct tests, especially in locations where driving stakes into the ground isn't possible. And the best part? It eliminates the need for temporary ground stakes altogether. What makes the stakeless method truly shine is its ability to bypass the dangerous and time-consuming process of disconnecting parallel grounds and searching for safe places to drive the stakes. It's a preferred method when parallel grounds are present, and temporary ground stakes would be difficult to drive into the ground. But how does it work? Well, with just one tool, the 1630 2-earth ground clamp. This versatile tool can act as both a voltage generator and an amp clamp in one jaw. It's as simple as clamping on and measuring away. It even allows for measuring low leakage current in a building simultaneously. The stakeless method can also be used with 2 clamps attached to a 1625 2. The first clamp is placed around the ground conductor, generating a voltage. The second clamp then measures the current flow resulting from the voltage generated by the first clamp. That's the stakeless method, a practical solution for challenging environments. Next up is the selective testing method. This intriguing approach uses a current clamp and 2 stakes to conduct its measurements. Now you might be wondering, why is it called selective? Well, the answer lies in its unique ability to measure ground resistance at specific points within an installation. This specificity allows for detailed examination and is particularly useful when you want to isolate and check specific parts of an electrical system. Imagine this. The selective testing method is like a surgeon with a scalpel, making precise incisions to examine the health of a patient. In this case, our patient is the electrical system, and our scalpel is the current clamp and the 2 stakes. The current clamp, akin to a fluke 1625 2, is used while the electrode of interest is still under test. This clamp meter isolates the test current injected into the electrode under test. Meanwhile, the 2 stakes are positioned in the soil in a direct line away from the electrode of interest. Usually, a spacing of around 20 meters is sufficient. The earth ground clamp meter, an important player in this process, is placed around the electrode. This helps to eliminate the effects of parallel resistances in a ground system. And voila! Only the earth electrode of interest is measured. With the selective method, you can isolate and measure specific parts of an installation. Now let's move on to the soil resistivity method. This method is particularly useful when planning new grounding systems. It's a prudent step to understand the characteristics of your ground before you start installing. The soil resistivity method involves using 4 stakes, and it's typically used to assess the ground conditions before installing an earthing arrangement. You see, factors such as soil composition, moisture content, and temperature all significantly impact the resistance measurements you'll get. Therefore, this testing is indispensable for determining the grounding system design. Imagine you're about to build a house. You wouldn't start without first understanding the lay of the land, right? The same principle applies here. Before you commence with your grounding system installation, you want to ensure that you're familiar with the soil conditions. Ideally, you'd want to find a location with the lowest possible resistance to work with. This method is also handy for reassessing an environment after significant changes, such as a drought. To perform a soil resistivity test, you connect your earth ground tester, like the fluke 1625, 2 to 4 stakes in the ground. The tester will generate a known current through the outer 2 stakes, and the inner two will measure any drop in voltage potential. The tester then automatically calculates soil resistance using Ohm's law. The soil resistivity method helps you understand your ground before you start installing. It's a helpful tool in your grounding system planning arsenal. Finally, we have the fall of potential method. This technique utilizes two stakes and the electrode under examination to validate the proper installation of a system. Not only that, but it also checks the grounding system in place before the construction of a building or as part of a routine maintenance program. The concept is straightforward. The first stake, known as the current stake, is placed in the ground, away from the grounding electrode. The other stake, dubbed the potential stake, is placed between the grounding electrode and the current stake. A known current is then sent through the ground from the grounding electrode to the current stake. The potential stake measures the voltage drop, or fall of potential, between itself and the grounding electrode. This method's beauty lies in its simplicity and effectiveness. It provides a reliable measure of the ground resistance at any particular point, helping to ensure the grounding system's overall safety and efficacy. Now, it's essential to remember that each of these four methods we've covered, stakeless, selective, soil resistivity, and fall of potential, has its own strengths and ideal applications. Choosing the right method depends on the specific circumstances and requirements at hand. And that concludes our exploration of the four methods of ground resistance testing. Remember, understanding these methods is key to ensuring electrical safety and reliability.